This is a series of videos designed to summarize years of psychology, neuroscience, and educational research into how people learn best. First up is a general summary addressing some big ideas and common misconceptions. Then we'll dig into techniques in multi-tail until you have a practical, proven, and multi-pronged toolbox to tackle your learning. First up, the most important thing to know is that your brain isn't fixed. It changes every time you learn something new. It physically changes. This is called neuroplasticity. In one study published in Nature in 2004, two groups of people were tested. One group learned to juggle and the others didn't. A few weeks later, scans showed that was actually more grey matter in the brain of the juggling group compared to the non-juggling group. Learning actually grows your brain. This effect did diminish over time. 3 months later, it wasn't so obvious, but it was still there. That means that regular practice is needed to keep the changes that your brain develops, but that practice becomes easier over time. Now, the thing is, your working memory, the stuff you can hold in your head right now, is super limited. Think 5 to 7 things max. To remember something long-term, you go think about it deeply, revisit it, and try to pull it back out on a regular basis. Working memory is like a bunch of sticky notes with one thing written on each of them. However, your long-term memory is like a well-organized filing cabinet with index cards and different folders of similar stuff. Your aim is to get those sticky notes organized and into the neatly arranged filing cabinet. There's a few ways to do this, but you do have to understand something first. Learning requires work. It requires your effort. If you're not willing to put in the effort, then you will not learn. There is no such thing as passive learning. Let's try a little memory game here. I'm going to give you 10 random words and you'll have to remember them. Ready? Banana, castle, laptop, rocket, shoelace, elephant, mirror, drum, pencil, rainbow. Now grab a piece of paper and write down as many as you can. You have 15 seconds. Time's up. Here's the words again. Give yourself a mark out of 10. Banana, castle, laptop, rocket, shoelace, elephant, mirror, drum, pencil, and a rainbow. How many did you get? There's a few different things you can try to help get those post-its organized into the filing cabinet. Perhaps you can try one thing. I'm going to give you another 10 words, but this time I've grouped them into categories. It's called chunking. You ready? I've got 3 animals: elephant, monkey, tiger. I have 3 things that fly: a rocket, a bird, an aeroplane. And I've got 3 fruits: a banana, an apple, an orange, and just a random thing that you use every day, a pencil. Okay, you've got 15 seconds again. Write down as many as you can. Time's up. Here's the words again. Give yourself a mark out of 10. 3 animals: elephant, a monkey, tiger. 3 things that fly: a rocket, a bird, an aeroplane. 3 food: banana, apple, and orange. And finally, a pencil. Was that any better? There's many more techniques we can use here, dual coding, for example, but we'll look at those in a different video. For now, let's just quickly recap. So your brain is plastic. That means you can physically change its structure and shape, and it will stay that way. This does require some effort, but like weight training or fitness training, using the correct technique backed by scientific research is better and more efficient. Your job is to get the items in your limited working memory space into the unlimited long-term memory by organizing and filing that information into neat but interlinked folders. There is a big problem here, though. Your brain is going to try and sabotage this process because sometimes it can be very boring, and your brain does not want boring. It wants dopamine. Dopamine is a chemical messenger in your brain. It's often called the feel-good chemical, but it's really more like a motivation signal. It helps control 3 things: what grabs your attention, what you want or look forward to, and whether you keep doing something, even if it's boring. When your brain expects a reward, like a TikTok ding, a game level up, or some sort of praise, it releases dopamine. That little hit makes you pay attention, stay interested, and want more. But here's the problem. Phones and apps are built to hijack your dopamine system. They train your brain to expect fast rewards. So when you try to do something like studying, which has slow rewards, your brain says, boring, where's the fun stuff? And here's more bad news. As a teenager, your brain is still developing, which makes it extra sensitive to dopamine, which means rewards feel more exciting, more urgent, making teens more likely to chase instant gratification, like thong pings, and find it harder to focus on slow, long-term goals like studying. The good news is there's lots of research on distraction and how the brain copes with that. It's called cognitive load theory. Short version is that the human brain can't multitask. You can't do two things at the same time. You can't listen to music and study at the same time. You can't quickly check a reel halfway through a study session. This distraction kills all the hard work they've been putting in so far. So you need to make studying get more rewarding. Set yourself short goals and mini rewards at the end of that. Use timers and streaks. Keep a track of your progress so you can take off things as you're doing them and see what's happening. You need to limit distractions that steal your focus. So in particular, with your phone, you need to turn notifications off. Put your phone in another room. Use the Pomodoro method, which is study for 25 minutes and break for 5 minutes. You need to give your brain a little break before it starts getting bored. We need to talk about one more thing before we move on and dig into some of these techniques in a bit more detail. So here's some questions. Have a little think about your answers. What is your learning style? Are you a visual learner, an auditory one? Do you prefer kinesthetic learning, that means moving around, touching things? Or do you prefer just reading, writing notes? So there's a lot of rubbish kidding around about this stuff, so let's just clear it up. Different learning styles do exist, and you may have a preferred learning style. But multiple studies conclude that there's no compelling evidence that teaching to your preferred style actually helps you learn better. Here's a quote from a major meta-study on this topic. We conclude, therefore, that at present there is no adequate evidence base to justify incorporating learning style assessments into general educational practice. This means that your preferred learning style actually makes no difference to how you actually learn. Instead, you should be using multiple learning styles when you study. Each of these styles uses a different part of your brain, so by combining them at the same time, by creating multiple linked paths in the brain and making those memories stronger. The big takeaway from decades of educational research is that humans more or less learn the same way. This is good news, as we can get you the techniques that have been proven in multiple scientific studies to improve your learning. You just need to start studying better, not harder. In the next video, I'll show you how you can learn more by doing less, just in a more organized way.